Brightics Studio provides over 130 machine learning functions and also supports auto machine learning and deep learning. Brightics Studio shows a high performance in big data processing. In this session, after going over basic concepts essential for modeling practice, we will practice regression and clustering modeling using data analytics functions in Brightics Studio. For this session, it is important to be aware of the basic concepts of regression, clustering, and holdout validation. To begin with, regression. It is a machine learning algorithm calculating relationship between X and Y column. The regression is the most common model that data science beginner starts with. Clustering is a method of grouping similar things together to form a cluster from given data. Clustering has been used not only as a general technique for exploratory data analysis, but also in many fields, such as marketing. The holdout validation is one of the machine learning model evaluation methods. As in the screen, it will proceed in the sequence of dividing the given data set into training and test data sets, creating a model with the training data, making a prediction model with the test data, and evaluating the prediction result as well. In this session, we will apply the holdout validation regression model. The first practice is making a machine learning regression model with Brightics Studio. Let's create a model. Click New button and enter the name of the model. If you click OK button, then the diagram editor will appear. Now we are ready to do analysis modeling. Let's load data first. Read data using the load function. Here, we will use Satosa data file already stored in modeling practice session. Click OK button and run. We will test the regression model later with the holdout validation, splitting data into training and testing. The holdout validation requires the split data into two sets, one for training and the other for testing. For that job, Brightics Studio provides split data function that splits whole data set to training and test data sets. Place split data function on diagram editor. Set required parameters given in the split data property panel. Here, we are going to use split ratio 7 for the train set and 3 for test set, and specify the need for the random number generator as 1, 2, 3 at discretion. The seed number you choose is the starting point that will be used in the generation of a sequence of random numbers. Click Run button, then the results are out as shown on the screen. You need to pay attention to two outputs in the Out panel on the right. This indicates that split data function produced two outputs. To check output details, go to the Chart Settings menu. Click Data tab and check Data Source. When you click on Data Source, you will see two data sets, Split Data 1 and Split Data 2. If you click Split Data 2, you can see the test data, which is the second data set. The total number of data rows is 15. If you click on Split Data 1 data source, the first data set, you get 35 data rows. You can also see two sets of data at the same time. To do so, you can use duplicate function located in the Output panel menu bar. If you set one data as Split Data 1 and the other as Split Data 2 using Chart Setting Data Source, you can see two data sets at the same time on the screen. Next, we'll train data with linear regression function. Find and place the linear regression train function to the right of split data. Input data was set train table as default. Next, set feature columns. Set X column as Sepal length and Y, the label column as Sepal width. Let's use the default options for intercept and other parameters and then click the Run button. The linear regression results are presented on the right output panel. The values described here imply the regression model describing the relationship between Sepal length and Sepal width with R-squared value and coefficients. Here, we evaluate the regression model using the holdout validation. Following the holdout validation steps, we will produce the predicted Sepal width using the regression model with the test data first. Find and place the linear regression predict function. You can see the linear regression predict function requires data and model as inputs. Connect the newly added predict function with the existing train function. Then, the model input will appear. Since we produced test table data set from split data function, connect split data function to linear regression predict function. Now you can see the train table as input. By default, Brightics Studio links the first data table, i.e. train table. For the holdout validation, train table needs to be replaced to test table. To do so, click on Inputs in the Property panel, then Set Inputs window opens. To link the test table, click X button and remove the train table. Then drag test table into Drop Data area. The data is then replaced to test table. The input table shows 15 test data rows indicating connected properly. Now, click the Run button to get predictions for the test data. Predicted values for Sepal width are obtained in the prediction column. You can see them on the output panel. Next, let's evaluate how well we predicted with the evaluation function. Place the evaluate regression function. If you enter the eval keyword, you will get 3 functions. Evaluate classification is an evaluation function used for classification prediction. So here we'll use the evaluate regression function. We will compare the measured Sepal width with the predicted values from the regression model. Let's set conditions for evaluation. In the label column, select Sepal width representing the measured value. Next, select the prediction value for the prediction column, then click the Run button. Now you get the evaluation results on the right panel. Next, let's look at clustering analysis. Place the load function to load the sample iris data. Sample iris data has 3 different species values. They are Setosa, Virginica, and Versicolor. Click the Run button to execute. Let's look at the data. You can see 3 kinds of species. Next, place a k-means clustering function. Select Sepal length and Sepal width as input columns. Next, set the number of clusters k to 3 and execute the function. The result is on the right. Let's take a look. You can see that you have a prediction column and that 3 values of 0, 1, and 2 are assigned. In other words, it was formed into 3 groups. Let's draw a graph and check it. Select a scatter plot chart in the chart settings. Set color by option to species column, representing actual data pattern. Then we will duplicate this graph and set prediction column in color by option. Clustering results are shown in the right. If you compare two charts, you will find that Setosa column is likely to be classified as 0, Versicolor column as 2, and Virginica column as 1, individually. And remember, the number sequence may be different since the k-means function has randomness in itself. Let's evaluate how well this classification has been done. For evaluation, the evaluate classification function is used. The real class values are in the label column. Select species column and select prediction for the prediction column. Execute by clicking the Run button. You need to pay attention that species column is string type and prediction column is integer type. We get an error because string and integer type are not comparable parameter, so we have to do the following. After moving the function to the right and disconnecting the connection link, place the add column function here. Add column is a function that inserts a new column in tune with a condition. Click the Add Column window and enter a condition. Set the new column name as pred and set the condition. Set the condition such that it should be assigned to Setosa column if the prediction is 0. It should be assigned as Versicolor column if the prediction is 2. And the rest to Virginica column. Click OK to set the condition. Click Run and you will obtain the results. Check out the results in the Output panel. Let's make the settings for the evaluate classification function. Change the prediction column to the string pred you just worked on. Click the Run button. Let's look at the results. We have got the confusion matrix and its performance metrics as the evaluation index. We have F1 measure value, accuracy and recall values. The overall results are shown to be good at over 80%. Thus, we have completed the practice session for clustering analysis.